Assalamualaikum warahmatullahi taala wabarakatuh. So today we will learn a new topic which is shaft and shaft component analysis. Uh, who hasn't seen shaft? Who hasn't seen shaft? I think everyone knows what is shaft. Instead, maybe some girl, your clique girls, don't know what is shaft is. So shaft basically you can see it anyway. Sometimes the screw itself call it a shaft, but you don't realize it. For example, as this figure shows, in our DC motor, nampak kan DC motor? Di tengah-tengah tu ada shaft. Itulah kita panggil the shaft. You can see it as an axle also. No problem. Contoh shaft yang lain, kita boleh nampak dekat rim bicycle, rim motor. Kita ada hub shell kan di tengah-tengah tu, kemudian ada screw yang panjang kan. So that screw ataupun axle kita boleh panggil dia juga sebagai shaft. Okay, and also I just remember that I also teach you subject energy and power. We learn about crankshaft, we learn about camshaft. So that is the shaft. Okay, shaft. So in shaft design, there's several factors you need to consider. For example, material selection of shaft. If you do design a shaft for DC motor application, so the correct selection of material must be known for your application. Kalau you just ambil saja any type of material, probably that your shaft will be snapped into two, broken, get enlarged, or have some problem with fatigue, some says. Okay, it depends on your application, but the material selection is the most important thing lah. And the other thing is on geometric layout. You must know your geometric layout of your application so that your shaft design will be meet to your need. Okay, and the stress and strength of your shaft design, you must consider it. Under the stress and strength, you must test the static strength, you must test the fatigue strength of the shaft of your design, and furthermore you need a deflection and rigidity. Under that, you must have a bending deflection test. In order to have a very good shaft design, you must do some bending deflection test and torsional deflection test. All these tests, actually you have learned it in strength of material. This in static, you learning at static, and this you learning in strength, in the strength topic. Okay, and vibration, we not cover it in our course on the vibration. Basically, to design a good shaft, you must consider at least 4 items: material selection, geometric layout, stress and strength, deflection and rigidity of the shaft, and the last one is on the vibration, which is due to normal frequency. You know vibration? Sometimes designer forgot to consider their shaft design about on the problem regarding on vibration, because vibration, if you have design that close, if you have a shaft design that close to natural frequency of your design, your shaft design, you might have a problem when your shaft design attenuate ataupun rotate at certain frequency close to their natural frequency. So your shaft will broken due to natural frequency. There's some other factor. For example, you must know aeroplane. For example, the tendency of aeroplane have a failure. It's more to the vibration itself. Because kapal terbang, for example, aeroplane, they akan vibrate along the time when they fly, when they operate. So basically, designer try to make all those components in the aeroplane considering their natural frequency also. Okay, if the design or any design component close their natural frequency, which means they are having a problem later if they are using that design for any application. For example, for aeroplane, bicycle. For example, bicycle is not that critical, but for airplane, if you design a component that close to the natural frequency of the component itself, it will be self-broken when you're using at natural frequency. Do you understand, you know? For example, I have a pencil here. I have a bicycle there. I have a bicycle there. I have a shaft inside the shell. Then I operate the bicycle at certain frequency. Maksudnya saya kayuh dia, kemudian ada satu benda yang bergerak ataupun bergerak dan dia beralun dan dia menghampiri sama dengan frekuensi shaft awak tu, dan shaft awak tu dia akan mengalami satu masalah natural frequency bila kayuhan saya tadi ataupun apa-apa komponen yang menyebabkan bila saya kayuh tu akan menghasilkan frekuensi. Bila saya kayuh basikal, dia akan menghasilkan satu frekuensi yang hampir sama dengan natural frequency of the shaft. So the shaft will eventually broken, eventually fracture as due to natural frequency. Okay, every component, every type of material has their own natural frequency. So this vibration is the most important thing if you are designing some component that interact with life of person. Okay, life of person. And shaft design, the first one, you need to consider on their own material. If you want to design a shaft, you must consider the first thing first is the material, because you can read it here. Deflection primarily controlled by geometry, not material. So if you design a shaft, you must consider the deflection of that shaft. So if you read carefully here, your shaft can be deflect not because of you are selecting a not suitable material, but most probably because of that geometry you are designing of that shaft. Okay, for example, you are using axle size of 10 mm for a bicycle, 10 mm for a bicycle. Then the size of the shaft itself is not the best size for bicycle for 10 mm. At least bicycle need 14 or 15 mm of shaft. So the deflection will be occur to your shaft. So that point is when you design a shaft, you're not checking or you're not controlling your geometry into a proper dimension. So it's not a wrongdoing ataupun wrong selection of material, but a wrong geometry of your shaft itself make the shaft fracture or broken. Okay, and the stress to control by the geometry, not controlled by your material selection. Okay, and what does material stand to? If you select a a proper material, what does it control? For the shaft, is only control on the strength itself. Okay, major selection of material only control the deflection. The selection of material only control your strength, not controlled by the geometry, not control the stress itself, not control the deflection of your shaft, control the stress of your shaft. The selection of the material. Selection of material only control your strength of the shaft, not control your deflection and control your stress upon the shaft. Okay, you must consider, or you must take note if you are designing a shaft. Furthermore, a shaft material, shaft are commonly made from a low carbon. Selalunya shaft dia tak buat daripada satu material yang highly carbon lah. Kalau highly carbon dia akan brittle, so dia made from low carbon, so it can be bend, it can be deflect. So shaft selalunya macam tu, dia akan buat dia low carbon. Bila low carbon, you can made it from cold draw method. Cold draw method ataupun hot roll method. Ni method untuk menghasilkan shaft. Method untuk menghasilkan shaft. Selalunya shaft ataupun material yang digunakan untuk membuat shaft ni adalah jenis AISI 1020 hingga 1050. Okay. Kemudian fatigue properties don't usually benefit much from high alloy content and heat treatment. Okay, fatigue. Do you understand about fatigue analysis? I think everyone knows about fatigue analysis. For example, you have a paper clip. I want to make you understand about the fatigue itself. For example, you have a paper clip ataupun paper clip pernah jumpa tak paper clip? This is a paper clip. Okay, paper clip ni, for example, you straight dia, kemudian you try to bend cyclically. You give a load in the cyclic manner on the paper clip tu. You try bend dia up and down, back and forth, naik atas, turun bawah, depan belakang pada position yang sama. So at a certain limit, berapa cyclic motion you dah buat, you punya metal dia akan start to lembik. Dia macam lembik lah, dia dah pergi ke plastic properties. Bila dah pergi ke plastic properties, itu dipanggil fatigue. You punya material tu dah pergi ke fatigue. So dalam shaft material, you nak dalam pemilihan shaft, selalunya orang buat daripada steel. Dia tak pergi ke alloy, high alloy ataupun ada heat treatment. Lepas you buat shaft tu, you buat heat treatment, secondary treatment lah untuk shaft tu, untuk bagi dia tahan. So basically untuk fatigue problem dekat shaft, dia tak akan membantu bila awak memilih type of material tu daripada alloy ataupun you try to make secondary treatment for that shaft. Untuk fatigue properties dia tak help pun macam mana. Okay, so basically untuk shaft, dia akan buat surface hardening saja. Okay, dia akan buat surface hardening, macam painting lah. Painting ni maksudnya you panaskan shaft tu sampai merah, kemudian you celupkan dia dalam carbon. Dia macam surface hardening lah, maksudnya dia punya surface of that shaft dia hanya keras di bahagian situ, tapi bahagian dalam dia still in the tile properties. Okay, that is shaft material. Furthermore, untuk cold drawn shaft, likely the shaft dimension around 3 inci saja diameter untuk shaft dimension tu. Untuk lebih daripada 3 inci, selalunya menggunakan hot roll process. Hot roll, you nak hasilkan shaft yang diameter dia kurang 3 inci, selalunya proses yang dilakukan hanya menggunakan cold drawn. Cold drawn ni macam mana? For example, you ada satu bulk of material. For example, saya ada satu bulk of material stainless steel. Okay, besar macam ni, dipanggil ingot, besar lah. Okay, kemudian you ada satu acuan di depan, panggil dia die. Die tu berbentuk shaft awak lah. Okay, either shaft awak dimension dia ialah ataupun diameter ialah 2 mm ataupun 3 inci lah, kita ambil less than 3 inci. So the process untuk menghasilkan shaft awak tu hanya you press saja dalam keadaan sejuk, sebab tu kita panggil cold. You press dia ke die dalam keadaan sejuk dan dia hasil satu shaft mengikut saiz die ataupun die lah, die yang you letak dekat mesin tersebut, cold drawn die tu. Kemudian hasillah satu material ataupun satu shaft yang hanya boleh dibuat di bawah diameter 3 inci. So selain daripada tu, dia memerlukan hot roll. Okay, hot roll ni macam mana? Satu ingot of steel material kemudian dimasukkan dalam satu hot roll. Roll ni ada beberapa silinder kan, dimasukkan macam tu, kemudian akan hasil lah satu shaft berbentuk macam tu ke bawah. Kemudian low production quantities untuk buat shaft selalunya akan menggunakan lathe machine. Lathe machine ni satu mesin yang buat apa-apa saja komponen yang dia akan rotate dia. Selalunya lathe machine ni nak buat shaft lah, selalunya dia buat crankshaft pun boleh juga, ataupun camshaft, selalunya menggunakan lathe machine. Tapi lathe machine yang ada CNC lah, dia bukan lathe machine yang manual ni tu. Boleh juga menggunakan manual, tapi you perlukan high precision kalau nak buat camshaft ataupun crankshaft. Kemudian untuk low production quantities, selalunya dia akan menggunakan minimum material removal untuk buat shaft tu lah. Is the best design of bone. Kalau tak, you perlu secondary process untuk buat shaft kan. Contoh, you nak buat shaft tapi you nak buat shaft of diameter 2 inci. Okay, then from cold draw ataupun hot roll, you hasilkan shaft yang berbentuk 4 inci dan dia ada bending. So you need lathe machine to make it straight dan to remove all the excess material so that you can have 2 inci or 3 inci shaft. First of all, dia akan besar sedikit lah dia punya shaft tu, size shaft tu. Kalau for example you nak shaft diameter of 2 inci, dia akan masukkan kat lathe machine shaft, raw shaft yang bersaiz besar sikit daripada 3 inci ataupun 2 inci setengah. So dia akan lead, dia akan buang keliling shaft tu, material tu, akan hasil lah shaft yang kecil sedikit, inci yang you nak tu. Kemudian high production quantities, most probably the shaft produced by forming ataupun casting process. Apa casting process? Kalau you tak pernah jumpa orang menggunakan forming ni macam stamping lah. Dia masukkan material dekat situ, kemudian dia stamp, the stamp machine, dia stamp, kemudian keluarlah satu shaft bentuk diameter, ada macam crankshaft, macam camshaft, ada juga bentuk dia. Itu dari forming lah, dia stamp, kita panggil stamping ataupun forming. Ada juga yang melalui proses casting. Proses casting ni you buat mold dan menggunakan pasir. Sebelum you buat mold tu, you mesti ada satu model lah. Model tu sama ada dalam bentuk kayu ke, plastik ke, any kind of product lah, bukan final product lah. Guna final product pun boleh juga, no problem. Tapi selalunya dia akan menggunakan plastik ataupun besi. Plastik ataupun kayu. So that kayu ringan kan, ataupun plastik pun ringan. So bila dia buat sand casting tu, dia buat mold menggunakan pasir tu, dia akan lekapkan dia punya shaft dekat atas. Lepas lekap, kemudian dia buat bahagian atas mold pula. Dia akan lekap balik, kemudian dia tutup, dia tuanglah material atas mold tu. Itu dipanggil sand casting process untuk buat shaft. Sama, waktu buat forming ataupun casting, dia mesti ada excess material. So the best design is to remove the minimum material from that casting process or the forming process. If you're not clear about what is casting process, what is forming process, you can Google it, and you can find in the YouTube. You may find that it may help you to understand better on how engineer using a shaft. Next, on the shaft layout. If you are designing a shaft, you must consider a shaft layout. For example, issue to consider a shaft layout is exactly on the axial layout of the component. For example, here, ini adalah dia punya helical gear. Ni helical gear kan, ni helical gear. Di tengah-tengah ni shaft. Ni shaft ni panjang ni. So you nampak kat sini dia ada ni bearing. Ni bearing yang berbentuk silinder. Kita panggil dia taper bearing. Cylindrical tapered bearing. You boleh bayangkan tak dia nak pasang shaft ni, mula-mula dia kena masukkan dahulu bearing ni, kemudian dia tekan. Selepas dimasukkan bearing, baru dimasukkan shaft. Selepas dimasukkan shaft, baru dimasukkan helical gear. So you can consider, if you are designing a shaft for any component, you must design the axial layout of that shaft. Diameter dia kena consider. Ni diameter luar, diameter dalam. Dia mesti ada shoulder yang tepat dengan size of your bearing tu. Barulah dia boleh interact kan, dia boleh snap dekat that position. Kalau you tak ada size of dimension ataupun diameter yang betul, probably you punya shaft akan jatuh melorot ke bawah. Okay, so that's why you need to consider axial layout of the component. If you are 10 ataupun you are 1, if you want to design the shaft for your project. And the other one is supporting axial load. Okay, if you are using, for example, this machine, what kind of force reaction can hold this kind of axial force? Axial force ni maksudnya force yang melalui axis shaft tu. Apa yang boleh bantu dia hold in position of that shaft, hold in that position? For example, dia akan ada loading axial yang mengarah kepada you punya shaft ni. Contoh you punya shaft ni shaft, kemudian ada axial loading kat bawah ni. So apa yang membantu shaft awak ni tetap pada position dia? So you must consider supporting the axial load ni. So selalunya bearing punya position dengan angle of shoulder ni akan bantu dia. Okay, kalau you select not correct type of bearing pun akan masalah dengan axial load. So basically untuk axial load ni, bila orang nak design sesuatu ataupun orang consider nak menggunakan shaft dalam dia punya design, dia akan menggunakan type of bearing jenis tapered. Okay, jenis tapered. Nanti kita akan go through what is tapered bearing. Okay, tapered bearing. And the things you need consider if you are using shaft in your design is providing a torque transmission, because your shaft dia akan provide a torque. Kan, buat apa you nak ada shaft ni tapi you can transfer a torque? Apa itu maksud dia? For example, kat bawah ini, kat bawah shaft ini dia ada gear ataupun kipas. Gear macam ni, helical gear juga. For example, this is rotated macam ni, so shaft ni akan rotate macam ni jugalah. So you nak dia punya output gear kat luar ni rotate arah ke kanan juga. So macam mana input yang di sebelah sini, input yang di sebelah gear ni keluarkan sama output dekat gear yang berada di luar? Mestilah dia kena provide torque supaya gear yang di dalam input ini akan rotate you punya shaft pada angular speed yang sama dan akan transfer dia punya torque ke output gear. So you kena fikir bila you nak guna shaft dalam you punya design, you must consider torque transmission. There must be a torque transmission. Macam mana you nak transfer torque tu daripada input kepada output gear. Okay, and the last one on the assembly and disassembly. Kalau you design shaft, you must consider macam mana you nak assemble dia, macam mana you nak disassemble dia. You tak nak buat satu shaft yang you boleh assemble dia tapi you tak boleh disassemble dia. Yang paling teruk, you design shaft, you tak boleh assemble dia pun sebab you design diameter dia too big. Okay, you must consider that. So you can read through here. The geometric configuration of shaft to be designed is often simply a revision of existing model in which a limited number of changes must be made. Selalunya bila designer design menggunakan shaft, selalunya dia akan ambil apa saja design lah yang hampir sama dengan dia punya application, so that dia tak payah kira balik dia punya keperluan size of shaft tu. Okay, and this on the assembly and disassembly. Okay, for example, this is the flaw ataupun the problem of designing a shaft. They are not considering the gap between bearing here. For example, this is your bearing, ball bearing. Dia ada inner shell, ni inner shell, ni outer shell of your bearing. Kan, pernah jumpa bearing tak? Ni bearing, ni bearing. Dia ada inner shell, ni ada outer shell kat sini. Okay, sebelah dalam dia ada berbola lah. Okay, kalau bad design of shaft, nampak ni dia design shaft dia ni undercut. Dia membuatkan inner bearing tu bagus berada dekat hole, dekat shaft awak, tetapi dekat outer bearing shell outer bearing tu, luar tu, dia undercut. Maksudnya dia ada gap dekat housing tu, so dia akan floating lah, dia akan bergerak-gerak, shaft awak akan bergerak-gerak ni bila awak menggunakan dia. So the best design is to consider the outer bearing shell must be intact. Okay, must be intact with the housing shell. Macam ni lah design macam ni. Ni housing tu, ni awak punya shaft, kemudian ni bearing dia must be fully contact. This by measuring a properly dimension of your shaft shoulder. Ni shaft shoulder, ni shoulder, bahu shaft awak ni. You must design this properly based on the size of bearing itself. Okay, you must consider on the assembly and disassembly. Macam mana you nak disassemble dan assemble. For example, kalau macam ini dia ada skru depan dan belakang, tak ada masalah lah. You boleh masuk saja dari mana-mana you punya shaft ni. Tapi on this side, dia hanya ada satu saja cap yang you boleh buka kat sini. So shaft akan masuk, you akan load shaft you daripada sini lah. Bila you load shaft daripada sini, so you punya angle ataupun you punya dimension must be fully correct. Kalau tidak, you boleh assemble dia, but you cannot disassemble dia. Okay. For axial layout, the thing that you need to consider if you are designing ataupun you are using shaft in your design, you must consider on the axial layout of the component, where you want to put your bearing, where you want to put your helical gear. For example, here you have a bearing, you have another bearing on the other side. This is your gear, this is your another helical gear. So if you're considering axial layout of your component, you must consider the size of your shaft must be bigger on this side and slightly bigger to this side. Slightly, not bigger, slightly lower dimension, ataupun slightly has a small dimension of your shaft size on this side. For example, here lah, kan? This is the most bigger size for your shaft. Ni small sikit, ni small, begitu small lah. Sama juga dengan dimension on this side. Must have a shoulder to your shaft, so that you punya gear pun, you punya pulley ataupun you punya fan can stay at that position. Okay, dia tak wobbling waktu operation lah. This is an example. You kena decide what type of shaft you want to use, what kind of dimension, what is your diameter of your shaft for this kind of layout. Kalau you nak pakai satu jenis size, satu jenis dimension sahaja untuk proses ataupun untuk project ni, you can do that, but you need to use a sleeve. Macam ni, sleeve you lock you punya shaft tu in that position. You lockkan dia, kemudian you lock on the other side of the fan, you lock juga you punya pulley, and you lock juga kat sini. So you can see lah here, if you use one single size of shaft, one single diameter of shaft, you need a lot of sleeve to make your components stay at that position. Kalau you ada different diameter of shaft, you can minimize the use of sleeve, bearing sleeve. You also need, you need keyways so that you can transfer the top. Okay. Then again, supporting axial load. Saya dah bagi tahu tadi apa itu axial load. For example, load yang ada terkena kepada you punya komponen ataupun you punya shaft dalam keadaan dia dalam aksis. Contoh, baca kat sini, a tapered roller bearing used in mowing machine spindle. Ini you punya spindle punya mowing, mesin potong rumput yang tolak-tolak tu. You perlukan tapered bearing jenis tapered untuk support axial load yang dari axial macam ni, datang daripada axial, betul-betul terkena dekat awak punya C shaft tu. So you must consider your design of shaft must use a tapered roller bearing so that your punya shaft can withstand axial load rather than using ball bearing. Okay, ball bearing cannot stand with the axial load, but the tapered roller bearing consider the best to apply for the axial load. And providing torque to your shaft, you must use at least 2, 4, 6 types of method to transfer the torque. The first method is keys method. The other method is spline, set screw, pin, press or shrink fits, or tapered fits. You must know how to differentiate these type of torque transmission component. Okay, for example, you have, saya buat example yang sama. You have this gear, input gear. Ni input gear. This is your output gear. In order to transfer input gear to output gear, you need to use a shaft here. So to make your shaft rotate together with the angular speed atau angular acceleration of your gears ni, input gear, nak consider dia ada sama acceleration dekat shaft. How to make that? You must consider to use keys, spline, set screw, pins ataupun press or shrink fits ataupun tapered fits. Okay, keys ni macam mana? For example, ini you punya gear. Dekat gear awak ni, kalau kita lihat daripada hadapan sini, kan, kita lihat daripada hadapan, so kita nampak you punya gear ni berbentuk bulat, kan? Bulat macam ni. So inner diameter dia ada slot macam ni. Dia ada slot macam tu. Ni hole lah ni. Ni hole, dia berlubang. Ni gear awak. Gear dia kena bentuk bulat macam tu je lah. So you punya tengah-tengah untuk gear tu dia ada macam lubang. So that lubang dengan shaft pun dia ada berlubang. Lubang yang panjang. So that lubang you can masuk keys. Keys bentuk dia sebiji macam ni lah, keys. Bukan kunci, tapi dia macam material yang lockkan you punya gear dengan shaft in position. So dimasukkan keys ni, the slot masuk dalam sini, dan you punya gear akan masuk dekat slot sini. Okay, kalau dah masuk tu, so dia snap fit lah, dia bagus lah. So when you rotate you punya input gear, you punya shaft pun akan ikut rotate juga. So that is what is keys. So what is spline? Spline ni you punya shaft tu dia ada macam gigi-gigi siap-siap. Ni shaft ni dia ada diameter yang straight lah, maksudnya dia tak ada gigi-gigi. Kalau spline ni maksudnya dekat hujung, dekat sebelah yang ada gear tu, dia ada begini. Okay, saya malah rukit no, enggaklah dia ni. Ni. So you punya lubang ni macam ni. Ni shaft awak. Ni shaft awak. So you punya gear nanti akan ada macam ni lah, dia akan mat dekat sini lah. So that kind of shaft we call it as a spline shaft. Dia khas untuk masukkan you punya gear. Kemudian ada yang gunakan screw, ada gunakan pins, ada juga gunakan tolerance of the shaft. Okay, dia hanya gunakan press fit saja. So when you press you punya gear pada dimensi of shaft yang dia punya interaction dia, bukan interaction, dia punya overlap dia ataupun tolerance dia lebih kurang 0.01 mm, so dia akan melekat macam itu. So dia punya gear akan melekat pada shaft tersebut. Tapi itu sangat susah sebenarnya nak buat gear yang ada dimension ataupun shaft yang ada dimension yang almost similar tolerance to the press and shrink fits. Most of the time designer akan menggunakan keys ataupun set screw ataupun pins lah untuk dia punya shaft application. You can read through here. Keys are the one most effective because the slip fit of the component. Dia boleh tak terkacau dengan slip. Kemudian dia ada positive angular orientation kan, and the last one can design the key to be weakest link to fail in case of overload. Okay, kalau ada overload, kat mana dia nak mesin tu nak fail. For example, you nampak mesin kan, nampak mesin yang dia boleh makan orang, dia boleh lenyekkan orang. So dia nak design satu mesin yang mesin tu dia akan fail bila tangan orang ataupun kaki orang tersangkut kat dalam mesin tu. So apa yang mula-mula patah? Key kat sini. So dia boleh design tu mengikut kehendak dia, mengikut kegunaan dia. So dia adalah safety point lah. Bila for example ada masalah, for example kalau you nak buat sesuatu yang mesin you menggunakan shaft dan dia nak mesin anything, then for example for safety reason of the user, dia termasuk tangan dia ke mesin tu, so ada extra load terkena oleh mesin, dan apa yang extra load tu nak buat, mungkin dia boleh patahkan key. So bila patahkan key, so mesin you tak bolehlah makan owners ataupun workers. So that is the way keys tu boleh jadi safety measure lah untuk you punya mesin. So this is type of keys and pins. And sometimes you can see keys are square. Dia bukan square macam ni, square cube tu tak, tapi dia square yang panjang lah. Bentuk macam ni. Okay, ada yang pins dia betul-betul pins lah, bulat saja macam tu. Ada yang dia betul-betul lock, betul macam pins, ni pin. Ada yang macam screw, dia letak screw kat sini. Ni you punya komponen, housing komponen, kemudian letak screw saja kat sini. So that shaft tu dia tak boleh pusing melebihi screw lah. So you punya shaft akan rotate on your application tu. Okay, begitulah dia. Dan tapered pins ni dia ada calculation dia. Bila masuk dia susah nak keluar selalunya. Itu, ini ada calculation dia. Dan keys come in standard square and rectangular sizes. Dan dia ada size yang tersendiri. Selalunya size tu, sebenarnya key ni kita bukan buat dia, kita beli dia. You nak gunakan size key yang macam mana, panjang macam mana, dan kekuatan dia macam mana, the depth pula. Okay, ini kita beli lah. So that much more easier for safety regulation. Baca kat sini kegunaan of keys. Failure of keys is by either direct shear or bearing shear. Keys tu boleh rosak sama ada dengan direct shear atau dengan bearing shear. Key tu sebutlah. Key length is designed to provide desired factor of safety. Dia punya panjang of key length tu mesti bergantung kepada factor of safety. Kalau factor of safety selalunya kita tak letak sampai 10 factor of safety. Selalunya factor of safety tu dia letak 2 ataupun 3. So dia akan menjadikan the weak link untuk mesin kita. For example, sepatutnya mesin tu hanya untuk buat curry puff. Okay, tapi you buat mesin tu you termasuk besi. So untuk mengelakkan dia punya mesin yang berharga 100,000, 200,000, 1 juta rosak, so the preventive ialah key tu ialah weak link. You kalau mesin tu buat kari pap, buat dough roti, you termasuk sudip ke, you termasuk cudu ke, you termasuk manusia sekalipun dekat mesin tu, so key tu dia akan patah. So you selamatkan mesin, you selamatkan juga orang yang termasuk mesin tu, sebagai contoh lah. Kemudian key length is limited to hard length. Panjang dia tu limited to hard length. You tak boleh buat sepanjang-panjang hard length. Kemudian key length should be not exceed 1.5 of shaft diameter. You ada satu diameter 5 meter. Panjangnya 5 meter shaft diameter tu. Contoh you ada lebih kurang 2 cm of your shaft, 2 cm diameter of your shaft. So you punya key length sepatutnya 1.5 kali saja panjang dia, jangan lebih sampai 1.5. For example, you punya diameter ialah 2 cm, 2 cm kali 1.5 lebih kurang 3 cm. So panjang key you jangan lebih daripada 3 cm. Okay, kurang tak apa, kurang tu dia akan jadi weak link lah, maksudnya dia akan for safety reason lah. Boleh juga menggunakan multi keys untuk carry greater torque. Selalunya dia akan oriented pada 90 degree from one to other. Itu maksud dia. For example, ini shaft awak, you nak gunakan lebih key, so you gunakan satu key di sini, satu lagi key di sini, oriented dia 90 degree. Okay, stock key material is typically low carbon, kemudian cold rolled with dimension slightly under nominal dimension. Dia boleh low carbon, maksudnya dia boleh dilentur lah. Dia tak nak cari yang brittle. Kalau brittle ni, kalau mesin tu dia ada tersentak saja dia dah patah. Kalau yang low carbon ni dia kuat-kuat tapi dia boleh datang, maksudnya dia boleh terbengkok sedikit. Right. Kemudian shaft juga selalunya akan consider to design a retaining slot untuk letakkan retaining ring lah. Tujuan retaining ring maupun retaining, dia akan membantu shaft awak retain on that position. Retaining ring ni pernah nampak kan, retaining ring ni. Now retaining ring must sit well in the bottom of groove to support axial load against the side of the groove. Okay, this requires shaft radius in the bottom of the groove. Ni kalau you decide you punya shaft nak gunakan retaining ring, so that you punya shaft stay in that position. So you must have a shaft radius. You tak boleh pakai chamfered radius, you must have a shaft radius of groove. Itu maksud dia. Typical stress concentration factor are high, around 5 for bending and axial, and 3 for torsion. Untuk faktor safety factor untuk retaining ring, selalunya kita akan menemukan 3 hingga 5, dan 3 tu untuk torsion dan 5 untuk bending dan axial. Okay, sebab retaining ring akan exert more bending and more axial load and more torsion load compared to the keys itself. On the keys, on the design, on the shaft design, it is not necessary to evaluate the stress in a shaft at every point. Kalau you design shaft, semestinya bukan sepatutnya penting untuk awak buat analisis untuk setiap point. For example, you ada shaft yang panjangnya lebih kurang 1.5 meter. Okay, You ada load macam-macam kat sini. You letak bearing, letak gear macam-macam kat sini. Dan you tak semestinya you kena kaji untuk setiap lokasi kat sini. Sebab dia tak penting pun you nak kaji untuk semua lokasi tersebut. Tapi yang paling penting ialah you kena study, you kena evaluate dekat critical location. Baca kat sini, critical location are usually on the outer surface of the shaft, where the bending moment is large, where the torque is present, and where the stress concentration exists. Remember, if you still remember using the static analysis, for example, you ada satu problem yang berbentuk macam ni lah. Problem yang begini, for example, ingat kan ini dalam statik kan, kemudian awak dipaksa buat shear bending macam ni. Bukan. You kena buat macam ni. Ni stress diagram, ni shear diagram. Kemudian you kena buat moment diagram. Ni moment diagram lah ni. So dia weakest link sepatutnya kalau ini adalah satu shaft, ini adalah satu shaft dan you ada load kat sebelah kiri dan sebelah kanan. So point yang you kena study ialah the weakest point dekat sini, where the highest shear stress berlaku, shear stress and moment berlaku dekat highest dekat situ. So you kena study dekat situ saja. You tak perlu study dekat lokasi yang sini, ke sini, ke sini. Tak perlu. Okay, you perlu study kat situ saja. When shaft stress analysis, untuk decide you punya diameter, untuk decide you punya diameter of shaft, selalunya dia akan ada 4 ataupun 5 formula yang you kena remember lah. But for me, it is good if you remember one type of formula, then you can use and apply it to your problem, to your design, to your capstone design, to your final year project design. Macam tu lah. For me, I prefer to use Goodman, DE Goodman ataupun distortion energy Goodman formula. Dia akan menggunakan formula seperti berikut: diameter of shaft D, kemudian dalam kurungan 16 N. N ni apa? Ialah safety factor. Kalau you letakkan safety factor untuk shaft awak ialah 2, so you put 2 lah kat sini, 2. So bagikan dengan pi dan kurungkan A divide by surface strength endurance, kemudian tambah P divide by ultimate strength of material. Ni ultimate endurance strength of material tersebut. Kemudian ni adalah ultimate strength of that material. Kemudian tutup kurungan power of 1/3. Okay, what is A? What is B? A is here, B is here. For example, tutorial number 1. Okay, tutorial number 1. A shaft is loaded in a bending and torsion such that MA is 70 Newton meter, TA is 45 Newton meter, MM is 55 Newton meter, and the TM is 35 Newton meter. For a shaft material, the ultimate strength of that shaft is 700 megapascal. The yield strength YS ataupun SY kat sini ialah yield strength awak berada pada 560 MPa, and fully corrected endurance is at 210 MPa. Assume the KF of the material and the KFS of the material with according to that number, and your design factor is 2. Calculate ataupun determine the minimum acceptable diameter of the shaft. using beberapa criterion. But in my cases, you must answer my problem in final test using a Goodman criterion. Goodman criterion for this problem is D equal to 12, not 16. Okay, 16 and pi A divided by endurance strength plus B divided by ultimate strength tutup kurungan power of 1/3. What is A? Refer to that equation. What is B? Refer to that equation, and plug all those numbers. You may get diameter of 25.85 mm. Okay, this is your job. You can try it at your room. Find the dimension or diameter of the shaft using DE Goodman criterion. If you get that figures, that number, you are plugging correct values to that formulas. Okay, and for this tutorial, it take a long time because we need to consider a lot of reaction forces, because to solve this question you need to draw and you need to know the value of max moment of your problem. For example, if you have like this, you need to draw moment diagram, you need to draw a stress diagram macam ni lah. Saya pun tak tahu kalau dia macam ni ataupun dia macam ni kan. So you need to draw this stress diagram dengan moment diagram, shear diagram. This bukan shear diagram dengan moment diagram. So you need to find this highest value berapa, this higher values berapa. So those values you can plug into this formula and you can find what is the dimension supposedly to this shaft. Okay, we will go into that on the tutorial side. Okay, that's it for today. Hope you learned a lesson. Hope you can go read it back and try this simple analysis. You can also try by yourself by looking at the textbooks that given to you. You can solve it for yourself. We'll go into that later on the tutorial session. That's it for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh.